So today I'm going to talk about building a gateway for a distributed system like a microservices architecture, and we're going to focus specifically on resilience and security. Now, quick poll. How many of you are using Java? Raise your hand. What about Spring? Do you use Spring? Nice. Now the next question. Do you use Java 17? 2 people. Nice. Yeah, so are you planning to migrate to Java 17 at some point? Yeah. Yeah, it's really great, not just for the features, but also for improved performance and security. I'm going to use Java 17 today. I'm Thomas. I work as a senior software engineer at Systematic, a Danish software company. I'm really passionate about anything cloud native. I'm also writing this book about Spring Boot and Kubernetes. I'm a big supporter of open source technologies. I like contributing to several projects whenever I have time, including Spring Cloud and Spring Security. Before talking technologies, I'd like to focus on the API gateway pattern. So which problems can we solve using a gateway in our infrastructure? Let's look into some scenarios. The first scenarios is about systems where we have different clients with different needs, that require different APIs. So for example, you have IoT devices, you have mobile applications, web applications, and some of them might require different APIs, but you don't want necessarily to update all your services in the backend to support different APIs. So having this gateway in the middle, converting and exposing a more customized and tailored API to your clients might be useful. Another scenario is when you have a monolith and you decide that you want to start extracting some functionality as microservices. So we call it strangling the monolith. When you do that, you don't want to disrupt the services for the clients. So having a gateway in between, we can guarantee an consistent and coherent experience for the clients while we do all these changes in the backend. So we decouple the two things. Next, we might want to provide a unified interface for the clients. Not just might, we should do that, because if we switch to microservices, we don't want clients being responsible for keeping track of all the microservices and discovering them. The clients should call directly the gateway, and then the gateway is responsible for keeping track of all the different microservices. So this is also a part of decoupling clients from whatever happens in the backend. So we are free to change things in the backend without having necessarily to change the clients. And finally, since we have this component available that represents the entry point to our system, we might want to use it in order to implement some cross-cutting concerns, like resilience and security is the ingress point to our system. So it's convenient to put some logic in there instead of duplicating it everywhere in a distributed system. This one is an example of a microservices architecture. You can see we have different types of clients, IoT, mobile, browser-based applications like a single-page application with Angular. We have a gateway, and then we have some microservices in the backend. In this example, they are Spring Boot applications, but they don't have to be Spring Boot applications. We can have different services using different languages and different frameworks. It doesn't matter. Today, I'm going to show you how to implement the gateway with Spring Cloud Gateway. But that doesn't mean that you have to use Spring Boot everywhere in your infrastructure. In particular, I want to focus on what happens when we add a gateway, because we are adding a new component to the system, a new component we have to implement, we have to maintain, we have to operate. So we need to consider pros and cons of this choice. And also we are adding an extra hop in the traffic flow that maybe in most cases it doesn't matter if it's done in an efficient way, but in some use cases it might be a problem. So as always, there's no silver bullets. We need to consider all the trade-offs when we make a decision. Today we're going to focus on a simplified version of a library system. We have the users, which are members of the library. They call the edge service. The edge service is the component that implements not only the API gateway, but also all those cross-cutting concerns that I mentioned earlier. So we call it an edge service. It's at the edge of the system, and besides the gateway, it also takes care of other different cross-cutting concerns. Then we have several services in the backend. Today we're gonna focus on book service as an example, but the same will apply no matter how many services we have in the backend or their languages and their frameworks. So let's get started and look into this sample application. So I have already built the book service application, so we can have a look. It's a very simple Spring Boot application. We have the main method initializing the application. Then I use the record in order to model a book domain entity with just one field, the book title. And then we have a REST controller. So we want to expose a get endpoint /books that returns a collection of hard-coded books. So to make things easier, I'm not using any persistent technology here. It's a reactive application. I'm using the reactive stack provided by Spring, so you can notice that I'm not returning a collection of book, I'm returning a flux of book. Flux means that at some point eventually we're gonna get a collection of values, but it's asynchronous. And I'm also logging a message, so we can keep track of what happens when we call the application. So let me run it, and we can see how it works. Now, for sending HTTP requests, I'm using a convenient utility called HTTPy, which is usually referred to as curl, but for humans. And I think that's really true, because I can just write HTTP, then column 9001, which is the port where my application is running in my local host, and then /books. And I get the list back. And this is fine. So our next step now is to integrate an API gateway in our architecture. So the first thing that I want to do there is going to start.spring.io. From here, I can initialize a new Spring Boot project, either from here or there's also integration with common Java editors like IntelliJ. So I will initialize a new Gradle project. I want to use Spring Boot 2.6. The application is Edge Service. And I'm using the latest and greatest Java 17. The only dependency I need here for basic functionality in a gateway is the Spring Cloud Gateway dependency, nothing else. At this point, I can generate the project and open it in my IDE. I have already done that, and I have actually pre-configured both book service and edge service with some monitoring and tracing, because it will help us later to visualize the changes that we're going to make in the gateway. But besides that, it's an empty application. So I can open the Java class. So we can see we have the main method initializing the class, and it's empty. So the first step, since we want to introduce this gateway in the architecture, is making sure that if we send a request to the gateway, it's routed to book service. So the first step is defining the routing. I can configure it either in Java or Kotlin, if you're using Kotlin. Are you using Kotlin? Good. Yeah, so you can also use Kotlin or Groovy when you work with Spring. Yes, I'm using Java. I can use the Java DSL for Spring Cloud Gateway, or I can use configuration properties. Now, I'm gonna show you how to do that via configuration properties in YAML, not because I prefer YAML over Java, because Java would make things easier, but because in a real production scenario, I would use the configuration properties to configure routing, because it's something that you probably want to customize depending on the deployment environment. So I don't want to do that in Java. It's part of the externalized configuration principle. So I'll open the YAML file here. We can ignore for now the existing configuration. And what I want to do here is adding a new section for a Spring Cloud Gateway. We have a section for routes, and I can define the first route, which is the route to the book service. So I define it as a book route. This route will forward requests to book service. So as a URI, I will pass localhost 9001, but this is only useful when I'm working locally. I want to be able to override this value in a convenient way. So I'm going to introduce an environment variable. Let's call it book service URL. and then I keep that as a default value. So if I pass an environment variable called book service URL, I'll use that value, otherwise I have a default, which is valid for my local environment. Next, I need to inform Spring Cloud Gateway when we want to route the request to book service. So which are the conditions? And we can do that using predicates. There are many predicates available in the framework. They are really nicely documented on the Spring website. In our case, we want to make it easy. So we want to have a predicate depending on the path. So whenever we send a request with the path starting with /books, then we want to activate this route. At this point, the example is actually pretty boring. I mean, we are just doing some routing. Any other proxy could do this. But the real power comes next. So once we have a predicate, we match a request, and we know where to send the request, we can wait before forwarding the request and start doing some processing with this request. And we do that via filters. So a simple example would be to add an HTTP header to the request. So I can say add request header. Maybe the library system is a multi-tenant application, so it might make sense to specify a tenant identifier as a header, Acme. But that's not just for a request. Once we eventually send a request to book service, we get a response back. Then we can also do some post-processing of that response before sending it back to the client. So in a similar way, for example, I could add a header to the response. So we're dealing with books, so maybe the genre of the books, they're fantasy books. And I'll run the application and we can see how it works. There are many filters for different situations supported by Spring Cloud Gateway. You can also implement your own, but the existing ones are already very powerful. So from now on, all the examples that I show about resilience and security, they will actually rely on built-in filters. We'll see that in a minute, but first we need to ensure that the routing is working. So now I'll send again a GET request to the /books, but on port 9000. That's where the Edge service is running. And I get the same result as before, but now the request has been processed by Edge service. You can notice that we have the genre custom header. And since I have already pre-configured the application with some monitoring and tracing, we can even visualize in Grafana what's going on. So first, I'll check the logs for book service. Let's see where they are, because if you remember, every time we call book service, a new message is logged, and that message is enhanced with two information. Maybe it's not visible enough. Yes. So the first information there is the trace ID. It's the identifier of the collection of tasks that together process the request. And then the second one is called span ID. So it's the identifier of the specific task that is part of the trace. So what I can do is getting this trace ID and then moving on to Grafana. And in Grafana, I can query Tempo. Tempo is a distributed tracing backend, which is part of the Grafana open source observability stack. So I can copy the trace ID here, run the query, and I get the trace. So we can see three spans. The first one is a server type of span. It's when the Edge service receives the request. The second one is a client span. So it's when Edge service forwards the request to book service. And the last one, finally, is book service. We also get extra information about the class that is responsible for processing the request and the method. So we know that it's working. And we have our baseline. And that's about routing. But that's only the basic functionality of an API gateway. We want to make the whole distributed system more resilient. Resilience is about having the system available always, even in the face of adversities and failures. So we want to build a fault-tolerant system. And whenever we have a distributed system, we need to consider the fallacies of distributed computing. So the first example that comes to mind is the reliability of the network. The network is not reliable. So what happens if the request that Edge service sends to book service gets lost? Or maybe it arrives to destination, but then the response gets lost. Or maybe just book service is momentarily unavailable. That can happen as well. It might be momentarily overloaded, so it cannot really process that request. One thing that we can do is adopting a retry pattern. So we can retry the request a few times to see if the situation changed. This is specifically useful if it's a temporary issue or a network issue. And we can implement this as a filter. So I'll go back to the project. And in this properties file, I'll add a new filter. So the previous filters were really basic filters, so I use this compact syntax. For the retry filter, I will use an expanded one because we need to provide some parameters. So this is a built-in filter for retrying request. And then we need some arguments. For example, we want to retry up to 3 times. Retrying request might be dangerous because we don't know what happened, why we didn't get a successful response. Maybe book service processed the request, but the response got lost. So what happens if we execute the same request twice? That's where we need to consider idempotency. So for get request, for example, by design that should be idempotent, and that's fine to retry. But if you have a post request, maybe it's not a good idea to retry the request because you might end up having an inconsistent state in book service. We want to retry, in this case, only get request. Then we don't want to retry right away, like one retry attempt after the other, because we might, if book service is momentarily unavailable, we might risk to really send a DOS attack to it. It doesn't really help it recover if we keep bombing with a request. So what we do is adopting a backoff strategy. A backoff strategy means that each retry attempt waits a bit longer before being executed. So we wait with increasing delays. We send retry attempts so that we give book service a chance to recover. And I can provide some extra configuration for this strategy as well. For example, the first backoff could be of 50 milliseconds, and I want to allow up to 500 milliseconds of backoff. And this is it for retries. It's a built-in filter. But this doesn't always help. For example, what about all the other requests, the post request? What about other situations where the error is not temporary? Retries help if we have temporary errors. But if the system is down for a while, we want to fail fast. That's another principle of resilient. Fail fast and deal with the failure. So instead of keep sending requests, maybe for several minutes, even if book service is down, we could just send back an error to the client. Or even better, we want to allow a graceful degradation of functionality, so we could fall back to some default behavior. So maybe we have some caching in place. We have cached the previous response from the book service, so we could return that one. And we can do that with circuit breakers. And this pattern is not only useful in the gateway, but also in any other application where you have the situation that you are depending on some other service. So it's to make the integration point more resilient. So we have overall a more stable system. Circuit breakers are based on 3 states. We have this state diagram. The inspiration comes from electric circuits. So the default state is a circuit which is closed. When it's closed, it means that traffic can flow from edge service to book service. But if there are a lot of failures that go above a certain threshold, then the circuit breaker trips and the circuit becomes open. When it's open, no traffic goes through. It will wait in that state for a while. Then at some point, we'll switch to an half-open state. It's sort of an exploratory state. We allow just a few requests to see if the situation changed. So if the book service is back up and running, available again. If it is, then the circuit becomes closed again. Otherwise, it goes back to being open. An example can clarify how it works. For this example, we have a filter a circuit breaker filter in a Spring Cloud Gateway, but in order to make it work, we need to add an extra dependency. So if we are using Spring Initializer, we can add a dependency on Spring Cloud Circuit Breaker, which is based on the Resilience4j implementation. Resilience4j is a really nice library for implementing different resilience patterns. It's a Java library, so you can use it in any Java application. It's not tied to Spring. But with the Spring Cloud Circuit Breaker project, we have a more seamless integration with the framework. So I'm going to add that. And then in the application property file, you guess it, we add a new filter. So we have now a circuit breaker filter. We need to configure a circuit breaker. And we're going to define a circuit breaker called book service. And we want to really make the system more resilient and take care of users so that if something goes wrong, users are not impacted that much. So I really want to use a fallback for that. I can do different things as a fallback. An easy way is forwarding the request to another endpoint that I have in my gateway, taking care of the default behavior. So I can say to forward the request to books fallback, and then I implement this endpoint inside the gateway application. So if I go back to the Java class, I can define a REST controller here. Yeah, let's call it a fallback controller. And then a get method. For now we are just defining a fallback for the get method because it's all we have implemented in book service. Books fallback. And then in this case we have no caching, we have no other values that we might return, so we can just return an empty collection. So at least we don't show any error in the GUI for the application. And since also Spring Cloud Gateway is based on the reactive stack in Spring, I'm not going to return a collection empty, but I'm going to return a flux of void in this case because the type really doesn't matter. Get fallback, and then I return an empty flux, which is just an empty collection. At this point, the only thing that is left to implement is configuring the circuit breaker. So let me switch to the circuit breaker branch. And what we get here is the configuration. This is through Resilience4j. So we have the configuration for the circuit breaker and for a time limiter. Let's start with the circuit breaker. So we consider a window size of 10. It means that we monitor the last 10 requests, and if more than 50% of them failed, then the circuit trips and become open. After 10 seconds in an open state, the application, the circuit breaker, will switch to half open, and it will allow only 5 requests while it's in a half open state. If more than 50% of them are successful, it becomes closed, otherwise open. I also define the time limiter because the circuit breaker, probably we don't want it to wait too much time to receive a response from a book service. So if after 2 seconds no response is received, we just consider that as a failure. We don't want to wait too long. At this point, I can rerun the application. And in order to better visualize and understand how the circuit breaker works, I'm going to use once again Grafana. Since I have Prometheus metrics exported from Edge service, I have a dashboard provided by Resilience4j that I can use to monitor the circuit breakers. So let's give it a second until the application is restarted. This is a really nice dashboard. We can monitor not only circuit breaker but also other patterns implemented via Resilience4j. So perfect. We have the Edge service application, the circuit breaker, book service, and its state closed. So what I want to do now is using a tool called Apache Benchmark, AB, to send 10 requests to localhost 9000/books. This is the Edge service. 10 is the sliding window size that we configured in the circuit breaker. So if I send this request, all of them succeed, completed, so there's no failure. and the circuit breaker is still closed. That's because no error happened. Now I want to have an error. So what I'm going to do is stopping the book service application. And let's see how will that play out. So now that the book service application is down, all 10 requests will fail. It means that more than 50% of them are failed, and the circuit breaker should trip and become open. Let's see if that's true. We have a few seconds delay for Prometheus scripting metrics, so let's give it a second. Also, I'd like to focus on the number here, 0 failed request. That's because we have a fallback, so we're not returning any error. So still, there's no failed request, but the circuit is now open. And it will remain open for 10 seconds. After 10 seconds, it will switch to half open. So what I'm going to do now is starting book service again. Yes, and then I'm going to send one request just to see the circuit breaker switching to half open. So hopefully 10 seconds have passed. And now it's half open. So we have now 4 requests left, and then the circuit breaker will make a decision about whether to become closed or open. So if I send now 4 more requests, since book service is available and hoping that I'm not going to get any network errors, that could happen, right? That's the point of resilience. We should get the circuit back to closed. And now it's closed. So I think this really helps visualizing how the circuit breaker works. And it's a really nice pattern when we have integration point with any external system. So it can make our system really, really more robust. Next, let's move a bit out of resilience and talk about security. Now we have this component, the edge service is the entry point to the system. And we might want to use it for something more than just routing and resilience. So for example, if we have a user that is calling the system, we could make edge service responsible for authenticating the user. But then we remember that one of the reasons for actually using the edge service was, one of the scenarios was to provide different APIs to different clients. So maybe different clients have different needs in terms of authentication. So we might want to support the classic form login with username and password, or enable or disable two-factor authentication, hopefully always enabled. We can have a social login, like login with GitHub, login with Twitter. We can use SAML. Maybe it's the library organization already has an Active Directory in-house that they want to use for authentication. So how can we handle all those cases? And one solution which really helps decoupling all these concerns is using OAuth2 and OpenID. Because from the application point of view, we just make the application, in this case Edge Service, speak the language of OAuth2 and OpenID. And then behind the scenes, the authentication can happen via different strategies. So first we have the login part. So if talking about OAuth2 terminology, we have the user, we have Edge Service, which is an OAuth2 client, is the one initiating an authorization request. And the login part is not accomplished directly by Edge Service. Edge Service is just the initiator. Then we have a so-called authorization server, for example, Keycloak. You can use Okta. You can even use Google or GitHub. They are OAuth2 and OpenID providers to actually log in the user. So as a developer, I'm not concerned with how the authentication step happens. I don't have to deal with user management, with password storage, encryption, because there's a different and separate component working with that. So it might be another team. If it's something that we implement and manage in-house, it can be a cloud service. It doesn't matter. We speak OAuth2 in Edge Service. And after the authentication happens successfully between the user and, in this case, Keycloak, then Keycloak will issue some tokens and send them back to Edge Service. Now, the next challenge is we have a login step performed successfully in Edge Service. we also need to consider how to manage the session. So how do we store session data? How can we keep track of the login that is currently logged in? And also, since this is a gateway, how can we propagate this authentication context to the services in the backend, all the services downstream? And that's still something that OAuth2 can help us with. So what we have, now I'm focusing on a specific case where we have a browser-based application. We have a session cookie traditional session cookie between the browser and Edge service. Then Edge service keeps a mapping between a session cookie and the tokens. And every time it needs to forward a request to one of the services downstream, it will add the access token issued by Keycloak as an HTTP header. Now, this is true when Edge service plays the OAuth2 client role in the OAuth2 framework. There are some situations where the OAuth2 client role is played by the client application, like an SPA, for example, Angular. So I really recommend always using a backend application to do that, because it's more secure. Having these tokens exposed to the browser is never a good idea. So even if you don't have any backend, you just have the Angular application, somehow adopt a pattern like a backend for frontend pattern, where you delegate this OpenID and OAuth2 handling to a backend service. It's more secure. This when we talk about browser-based applications. So we have 3 things that we need to implement now in order to add user authentication to the system. The first one is that we need to integrate with Keycloak following OpenID so that the user can log in. The second problem is that we need to deal with session management. And we are hopefully scaling Edge service when we deploy it in production. We don't want it to be a single point of failure. So we have multiple instances of Edge service running. So definitely we want to keep them stateless. But session management requires some state to be saved. So what we can do is externalize that state persistence to some external system, for example, Redis. And that's what we're going to use. And then the third problem is, after the authentication step is performed successfully, how can we propagate the access token to the services downstream? So using what is called token relay. So we can do that. We're gonna rely on, of course, on the OAuth2 and OpenID standards. We're gonna rely on Keycloak and on Spring Security, and of course on Spring Cloud Gateway. So let's have a look. So first of all, I need to go back to my application initialization, because I need to add a couple of new dependencies. The first dependency I need to add is for Redis. I can add Spring Data Reactive Redis because I'm working on a reactive application. Then I want to use Redis for externalizing the session storage. And Spring provides a component, it's called Spring Session, which abstracts the session management so that you can use different storage strategies. So out of the box, transparently to the developer, we're gonna get the session stored in Redis instead of in memory. And finally, I need to add a Spring Security dependency specifically for the role that Edge service will play in the OAuth2 scenario, which is OAuth2 client. And that's it. Now, just by adding the OAuth2 client dependency, which is an extension to Spring Security, but focused on OAuth2 client, we'll get security by default. So all endpoints in our application are now protected and authenticated. But I still need to configure how to integrate with Keycloak. And I can do that in the property file. So I have this application YAML file. Let's move down here. So we have a client, and not that one. So we define a new client registration. Let's call it Keycloak. And in here we have to define a client ID and the client secret. Now I'll put a secret here, but really we don't want to do that, right? Yes. Then we have the client ID, Edge service, and we have the scopes. So the scopes are kind of permissions but for applications. In this case, I'm going to use an OpenID scopes because I want to enable the OpenID authentication layer, which is built on top of OAuth2. And then I need to define the issuer URI, which is keycloak. Now let me switch branch so we get all the correct values. And application YAML file. Yes. So we have client ID, client secret scope, and we have the keycloak URI. This is all we need to do to integrate with keycloak. Then automatically all endpoints are secured. We can further configure them, but for now I'm fine with having all endpoints requiring authentication, user authentication. This is the first step. Then I have to configure the session to use Redis, and I can do that with this property here, session store type Redis. And finally, how to integrate with Redis. I have a Redis instance running on my local host on port 6379. So we solved the problem of the login step and session management. We still need to deliver this access token to the downstream services every time we forward a request. And that's another filter. It's called token relay, very conveniently. So just by adding this filter, if an access token exists in the current security context, then is added as an HTTP header and forwarded down to, for example, book service. This is the part regarding edge service. We need to do something similar in book service, but easier because we only need to configure how to integrate with keycloak. So we have down here the configuration, this time as a resource server, which in OAuth2 is the server which contains the protected resource that we are trying to access. We are going to use JWT, a JSON Web Token, as the format for the access token, and once again we point to keycloak. So I can now run both applications again. So if you have, have you used keycloak before? Raise your hand if you have some experience. So there is a project to integrate keycloak into a Spring application. It's called the keycloak Spring Adapter that was commonly used. But now, as you can see, Spring Security has full support for OAuth2 and OpenID. So you don't need any keycloak dependency. So what I have shown here works in the same exact way if you use Okta, if you use Auth0, if you use GitHub, Twitter. You just need to specify a different URL because it's a standard. It's also why we like working with OAuth2 and OpenID. They are standards. So we have no keycloak specific code in the application. That was just an example. I could as well replace it with anything else supporting that protocol. So I have restarted book service. Let's restart edge service again. And now I'll open a private window so we don't get any cookie disturbance. And we want to access port 9000 / books. So let's see if the application started. Let's give it a try. And it started. So all endpoints are authenticated by default. So I'm redirected to this login page provided by keycloak. I have some users already defined in keycloak. One of them is Isabel. So let's log in. Password. And then I'm redirected back to the application. So I can see the list of books. So a lot of things happen behind the scenes, but that's also the beauty of this. Like, I don't have to work too much on getting this to work because it's a standard and it's provided by the framework. So what happened behind the scenes is that the user authenticated, keycloak issued an access token, edge service stored it in the session, and when we call the books endpoint, that access token has been sent down to book service, which also requires authentication for all endpoints. Accepted the access token, validated it with keycloak, and we got the response back. So once again, we have just a session cookie-based communication between the browser and edge service. And then we have the access token that is used to call services downstream. And in this particular case, we used a JWT access token, but it doesn't really matter because we haven't had to deal with it. It was relayed by edge service directly, and then the validation. So checking the signature of the token also happens automatically. Another nice feature that happens behind the scenes with this Spring Security implementation is that whenever the access token expires, Edge service also takes care of using the refresh token in order to get a new access token. So that's also something that happens behind the scenes. It's fully customizable, of course. Now, we relied on the default configuration, but already like that, it's really powerful. Next, I want to talk about observability. So Spring Cloud Gateway, and in general, a gateway is a good place for these cross-cutting concerns. We mentioned resilience, we mentioned security, but it's also a good place to deal with some observability concerns. Observability is a property that we really want in cloud-native applications, and it's about inferring the internal state of an application starting from its outputs, like logs, like metrics, like traces, but even more than that. So sometimes it's mistakenly confused with monitoring. So monitoring is part of observability, but with monitoring, we define alerts for known failure states. So we know in advance what can go wrong, and we define some alerts, and we define some metrics. Observability goes beyond that. Observability is about being able to ask questions about the unknowns. So something that we don't know, so we didn't monitor it because we didn't know that could happen. That's an important distinction. So what I have been using today for this presentation is an open source stack based on Grafana. So just as a reference, I used Grafana for visualization. Then I have Grafana Loki for logs. We haven't seen that because it was running locally, but it works if I run on Docker or Kubernetes. Just to gather all the logs, I used Prometheus for metrics. And if you need to scale, you can also use Cortex in order to deal with Prometheus at scale and with more data. And then Grafana Tempo for traces. And one of the nice features is that once we have all this different information in one place, we can really start asking difficult questions and navigating through all this different information, combining them together. For example, earlier I went and manually checked the trace ID from the log message and then copied that in Tempo in Grafana in order to correlate the two things, but that can be done automatically inside Grafana. So I can start by checking some logs, then a link is generated from a trace ID, so I can navigate to a trace, and then maybe from there I can navigate to metrics, which are related to that trace. I think it's really nice. It's one of the things that you really enjoy when something goes wrong in production and you have to solve the problem. Maybe you're called in the middle of the night. So having all the information that you might need to actually understand what's going on and how to fix it is really great. Thank you.